Welcome to another episode of Hanlon Lab Alumni Series. Today we have joining with us a very distinguished alumni, Dr. Dan. Hello and welcome to the show.
Thanks for having me.
So, Dr. Dan, you have done your master's and PhD in financial engineering from Stevens, and you worked at Moody's in the natural language processing department as a director. And after that, you went to a role of vice president or lead data scientist, where you were using machine learning for signal generation for portfolio managers at J.P.Morgan Asset Management. You are also recently promoted to a director, so congratulations for that.
Thank you.
Were your 6 years of research and experience at and education at Hanlon Labs and by extension at Stevens, did it help you prepare for any of the challenges that you face in your role?
I would say yes, definitely. So it was a long time ago when I actually spent a lot of time here during my master and PhD. So the key themes is that I learned from here that Hanlon Lab, I would say, enhanced my research ability. What it means is that as a master, I was more like instructed by the advisor to the advisor or professor will tell you you should do like this. And when I graduate and I become PhD student, I will be more given a topic, and the topic that is probably nobody know than you. You are most expert than your advisor. So you will do a lot of individual research, and you have to go back to discuss. I won't say teach your advisor, but you have to discuss the more novel themes that is your advisor might not as familiar with you. So I would say in this is very similar case with what we did in current, like in several years ago when I was IC, when I being instructed how to solve the problem, and then I dependently solve the problem. So this is a process. I would say mimic process when I did in the Hanlon Lab.
So the process where you're just given a topic to go and solve for a business problem, and you have no instructions or you have no process of how to accomplish it, and you have to figure out yourself.
Yes, that is more like as you as the VP level, your manager will tell you how to solve it. But if you're lower, like junior level, and your manager will step by step tell you you should do 1, 2, 3, which is like the master student. When you're a PhD student, you're more like individual to do the research and solve the problem by yourself. And then if you are in the high level right now, if you not high level, if you are in manager level, so you have to think about from the business model, from the business requirements, how do you translate this requirement as a mathematical model, and how do you decompose this big problem, complex problem into sub problem, and each problem fits which skill set for your team. So that is the task allocation is one of the skill sets of the manager.
What is a skill that you feel that the AI is the evolution of AI has generated a sort of gap in terms of a human skill that you can develop?
I don't see any gap actually, but it's actually huge improve on everything, especially efficiency. So one of the product I built is kind of boost research for portfolio manager. It can answer the question like, what if Trump take over Greenland? What will be impact on my holding? So this kind of research question will take 3 to 5 days to answer. But right now, it's the LM can extract all the information from Word, and build the agent will analyze how to decompose this question into multiple steps. For each step, how should you do it? And the final, what's your answer, and what's your holding, and what your holding will be impact. So this multiple chain of thoughts will be done within under 2 or 3 minutes. So it's significantly improved the research time for a portfolio manager.
So how accurate is this agentic stuff that you're building, given like you have the issue of like AI agents hallucinating, and what do you do to like cater to it?
I think it's a very good question. LM evaluation is a huge topic or hot topic in AI. So for each step, you need to evaluate by yourself. Like we have, for example, you have LM planning. How you plan is good or not. You should have a single evaluator to evaluate. If, for example, we have fact check. So we give a lot of facts. We know what happens in the market, and we ask LM to provide, and we evaluate if LM can produce correct answer or not. That is like fact check. We have the evaluation, we have citation, everything. We have the evaluator too. So even single point, single component in our agent flow, we will evaluate. So that is kind of a huge amount of work to make sure your agents are work smoothly and efficient.
So in terms of model risk management, what are like some of the techniques that you, apart from like fact checks, that you employ to make sure like all the predictions and let's say the signals that you're generating and for different let's say scenarios, that is because no one, like you don't know if that is going to happen for a fact, like you don't have any data that's existing that you can compare it to. So how do you know like?
So for those kind of, I would say, more open-ended question, there's the one mechanism called LMS judge. So we also have reflection. So this is several things you can use to evaluate if your result is first satisfy the user's requirements. Second, if your result is okay to be produced, and also several items you can define in LMS charge. So you can use LM to do. For those the question that don't have any like ground truth, I would say most of the most popular tool in the industry is LM charge.
J.P.Morgan and a lot of other banks, they had a whole report. They predicted, like for example, the price of Bitcoin gonna be close to $250,000, and now if you look at it, it's like not even near. So now you have, let's say, wherever the signals were generated, they priced it, and like if you look at the delta of what's happening. So this is why I asked, like, how much with confidence can we trust?
It depends. It depends on the task itself. Some simple tasks can have very high confidence. We have we call NER linking. So we use LM to link the entity from, for example, the NER, right? Name entity recognition. When you have name entity recognition, you have this entity, and then we have the database with a bunch of the ID. How do you link this entity with the ID? We call this entity linking. And this we use LM, and for this small, simple case, we have very, very high confidence task. And to answer the question about the confidence level of this one, of all more like you talk about complex question, that is, we usually break down the complex question into each sub-question, and to make sure each sub-question have high confidence. So make sure LM can deal with a simple task with high confidence, and then we can do like a waterfall to make sure the final or the whole confidence can be the whole project can be done by the high confidence.
Okay. So like in terms of like students that are looking to pursue financial engineering or computation finance, what do you like recommend that they adopt in terms of mindset, in terms of skills, given like you mentioned the technological landscape is evolving so fast, you don't know what's going to stick in the future?
I would say the basic is not changed at all. Math, finance, not finance, I would say math, statistic is most important. I ask statistics question, linear regression every single interview, and we use every day. So the basic skill set is never changed. So you have to know the basic mathematics statistical model, and you can know more complex model. So I would say the basic logic is never change. The coding itself you have to learn. If you don't know the coding, even produce the fantastic, or even though if you don't know coding, produce a codes with improved version, you don't know what is improved, why it's improved. Like you want to deal the task with, let's say I want to have the low latency, so you have to make sure the time complexity of your code is reduced as possible. However, if you don't know the code, you don't know what is the time complexity. So everything will be the very atomic level concept you have to know. That is the basic things.
Okay,
That is never change.
like the maths is gonna be the same.
Yeah, if you like the most complex of the like LM transformer, in the end for each node is still a regression. I'll say the active function can treat as like nonlinear regression model. So it's reduced to very simple model. Every complex machine, complex model, in the end is still the simple math.
What are the like latest requirements in terms of like students entering the industry or people looking to jump into data science roles in finance?
I would say, so coding itself for myself or for my team is less important, because right now LM can generate all the code for you. We are using LM to code every day. But code itself is very important still, which means the skill set or capacity to understand the code itself is more important to code itself. What does that mean? LM might be easy to hallucinate it, but if you don't have experience to code without LM, it will be very dangerous that you 100% trust LM, and LM might provide the wrong code and you cannot detect. So, in other words, if you have the problem and you know how to solve the problem using code, like or personal code or the logic to solve the code, it's more important than the code itself. Because if you know how to code, LM can generate this all code to you. You just need to figure out if LM generates the right code or wrong code. That is the key problem. So I would say reduce to very beginning. Make the algorithm is more important than the coding itself. So that is the coding part. And we are solving a lot of mathematical model, or we are solving a lot of like business model that need to be transformed into a mathematical model. So mathematic skill is also very important. I would say that is more important than code. Code right now is become less important. And I would say if you in the financial industry, of course, you have to some basic knowledge of financial knowledge. So that is the three dimension of, I would say, hard skill. You have, that is the basic skill sets you have entered the industry.
Machine learning has a black box in terms of interpretation. Do you feel like you face the same sort of issue?
People
right now?
still accept the black box. People start accept a lot of the same they are not accept before, because the performance is way higher than the same. So like rule based is being replaced. A lot of like operation stuff, rule based operation stuff, is already be replaced by LM. You even can provide a rule based to LM. LM still can perform the rule based all stuff, but it's all much more smarter. Much smarter and is more efficient, can handle more edge case.
And with a higher confidence.
Yes.
Okay. Thank you so much, Dr. Dan, for joining us. And again, congratulations on your promotion.
Thanks. Thanks for having me.